In this lecture, you are going to understand the hypervisor and the virtualization feature supported by the ARM architecture. Have you ever heard about the hypervisor? These days, hypervisors are widely used in various projects. The smartphone and the infotainment system in the automotive sectors are using the hypervisor. What is a hypervisor? Hypervisor is architecture or platform that allows multiple operating systems to run simultaneously. In the hypervisor system, we can call the multiple operating system as the guest OS or the virtual machine. Generally, hypervisors were originally developed for Intel x86 architecture for more than 50 years ago. But these days, ARM-based hypervisors are widely used in the automotive sector, and ARM architecture that is deployed in the automotive sector could be ARM version 8.8 architecture. But these days, number of the project is based on 64-bit architecture. So based on the ARM version 8 architecture, virtualization feature is supported. So based on the virtualization feature, hypervisor is under development. So let's take a look at some of the figures that illustrate how hypervisor is organized. If you take a look at the slide, there is hypervisor, and on the top of the hypervisor, you can see the perception OS, mapped and planning OS, ADAS OS, and infotainment OS. What you have seen is the architecture that is based on hypervisor system. Hypervisor is responsible for loading and managing resources of multi-operating system. In this example, hypervisor is taking care of the multiple operating system to feature of automotive system. In the hypervisor system, multiple operating system is referred to as the guest OS. There's a first guest OS and second guest OS and third guest OS and fourth guest OS that is managed by the hypervisor. Now let's take a look at the diagram that shows how the hypervisor is running based on the ARM architecture. And here, what you can see is exception level defined in ARM version 8.8 architecture. At exception level 0, usual application can be running. At exception level 1, the Linux kernel or real-time operating system can be running at exception level 1. And hypervisor is running at exception level 2. Why the hypervisor is running at exception level 2? Because hypervisor should running at exception level 2 because exception level 2 has a higher privilege level than exception level 1. Meaning the higher privilege level is that hypervisor can access the system register that is configured at exception level 1 where guest OS is running. Since the main job of hypervisor is to take care of the resources that is needed by the guest OS, hypervisor should measure the workload of each guest OS to manage some of the resources or some of the workload that is required to run each guest OS. So hypervisor is playing an important role to upload each guest OS to manage the resource of guest OS. An hypervisor can be implemented based on the feature of ARM architecture, especially with the virtualization feature. With using the virtualization feature, hypervisor can be running. The key feature of virtualization is hypervisor call and virtual interrupt. With that feature, hypervisor can be implemented to support the manage the each guest OS. This diagram illustrates the execution flow of the guest exit. What is the guest exit? Guest exit is performed in order to request service from the guest OS to the hypervisor by running HVC assembly instruction or WFE or WFI assembly instruction. When running this assembly instruction, guest exit is executed by passing the control into the hypervisor from the guest OS. During this operation, synchronous exception is performed. Now in this lecture, we got to know about how hypervisor was introduced, some of the key features supported by the ARM architecture on the virtualization. So next lecture, we're going to understand some of the key features that is supported by the virtualization in ARM version 8.8 architecture.